Alright, so this lesson is adding and subtraction. Let me try that again. Adding and subtracting rational expressions. So our learning target is I can add and subtract rational expressions. Crazy how I came up with that. Alright, so remember, rational just means everybody's favorite fractions. Yay, we love fractions. Just kidding, it's gonna be fine. Okay, let's take a trip back to elementary school. Hopefully you remember the only way that you can add or subtract two fractions is if they have the same denominators. So we have to manipulate it enough that they have the same. So here's what I want you to think about. Even if you weren't taught it this way, this is what I want you to do. I want you to look at that first denominator. It's got a 2. What does the first denominator not have that the second one does? So it does not have a 3. So what we're going to do is we're going to multiply a 3 to the top and bottom. So we didn't change anything because 3 divided by 3 is 1. Anytime you multiply something by 1, it stays the same. We're just manipulating it enough that we can do something with it. Okay, so now look at the second denominator. What does it not have that the first one does? Has the 3, it doesn't have the 2. So we're going to multiply the top and bottom by 2. So let me rewrite what we have now. So we have a 3 times 1, which is 3, divided by 3 times 2, which is 6, plus we have 1 times 2, which is 2, divided by 3 times 2, which is 6. So what we've done is we have changed it just enough now that they have the same denominator. And if you'll remember, you do not add the two denominators together. They stay the same. So the denominator is going to be 6, and then you just add the two tops together. So 5 plus 2. 5 plus 2. 3 plus 2 is 5. I told you the answer. And then if you could simplify further, you would, but this answer is complete. So we are using that same reasoning when we do this next problem, just with some linear monomial expressions. Same thing. So I put it in words. In order to add or subtract fractions, you must have common denominators. So what is kind of exactly the same as the one we just did. If you'll notice, that first denominator has a 2 and an x. It does not have a 3 like the second denominator. So we're looking for what does it not have, and whatever it doesn't have, we're doing to the top and bottom. So now when you look at the second one, it has the 3 and the x. It does not have the 2, so we're going to multiply by 2. Okay. So what we have right now is we have 3 and 15, which is 45, divided by 2x times 3 is just 6x, plus we have 16 times 2, which is 32, and on the bottom 6x. So we have that the fractions have a common denominator. Remember, you don't do anything to the denominator. It stays the same, 6x. And the two tops, you're just going to add across. 77. And then if I could simplify that down further, I would. But this is going to be my final answer. So hopefully that makes sense. Okay, so now we'll move to this one. We have a quadratic on the bottom of that first fraction. We need to factor it completely before we begin. So that's what I'm going to do. If I factor that first bottom, I need two numbers that multiply to give me -6. They have to add to give me +5. So a +6. And negative. Alright, so here's our next problem. If you'll notice that on the bottom of this one is a quadratic. And so because we don't actually see it in its factored form, you can't really figure out what the denominator needs to be. So the first thing I'm going to do is I'm going to factor this completely. So I need two numbers that multiply to give me 6, add to give me 5. Those numbers are 3 and 2. so with the other fraction, there wasn't anything that I could factor, so this is factored completely. I'm looking for what do I need to make the two denominators exactly the same. So with the first fraction, it has x plus 3 and it has x plus 2. So it's got everything that the second fraction has. The second fraction is lacking the x plus 3. So that's what we're going to multiply to the top and bottom. Let me rewrite what I have. So I have x squared minus 5. We didn't do anything to that fraction because it had everything it needed on the denominator. And the second fraction has now become x plus 2, x plus 3, and on top, x plus 3. Alright, so we can now add the two fractions together because they do have the same denominator. Remember, those are both the same expression, even though they're kind of flipped around. Okay, so we don't do anything to the denominator, and then to the two numerators, we're just going to add across. So there's nothing to add to x squared, and then there's an x, and then there's a negative 5 and a positive 3, which is just a negative 5. So at this point, you can think about, can you factor that top at all? And you actually can. If I factor that top, I need two numbers that multiply to give me a negative 2, but add to give me 1. So I got positive 2 and negative 1. And then on the bottom, I have x plus 3 and x plus 2. And what you're looking for is anything that they have in common. So they both have an x plus 2. And then it's just like those previous problems. I'm going to circle what's left. So I got an x minus 1. And I got an x plus 3. And that is my answer. So same thing for this one. Can't really move forward until we have this completely factored. So I want you to hit the pause button and see if you can factor it. Let's practice that. Okay, so like magic, it has been factored for you. So we're looking at the first denominator, and we're trying to figure out what does it not have. It does not have the x minus 3 that the second one does, so that's what we're going to do to the top and bottom. And then now look at the second denominator. What does it not have? It does not have a 4. So we're going to do that to the top and bottom. Alright, so I'm just going to clean this up a little bit. So remember, this is like we're distributing this 2 to everything over here. We're distributing this 4 to this parentheses. So go ahead and distribute, and we'll meet back up in 1 second. Okay, so everything's been distributed. So now they have the same denominator. Don't do anything to the denominator. And then we're just going to add the two tops together to put your like terms together. So I got a 6x and negative 3. Just always remember that you want to check to make sure there isn't anything that you could simplify a little bit further. So that top, it actually has a GCF. The GCF is 6. And when I take out a GCF, I'm left with x minus 5. So now let me do this. And you'll notice they both have an x minus 5. So let me write what's left and then see if you notice anything that could be reduced. So sometimes people don't notice this, but 6 divided by 4 can be reduced. They're both divisible by 2. So it's actually the final answer looks like that. If that didn't make sense, you could have thought about it being 6 is 3 times 2, 4 is 2 times 2. So notice both of these can take out a 2. So that's how you're left with the 3 over. Okay, so I want you to try this problem. There's nothing to factor, so you can just go ahead and start getting it to the same denominator. Just try your best. If you get stuck, you can play the video and then just pause it as you go. I'm going to let you hit the pause in 1, 2, 3. Okay, so what I hope you have seen is that the first denominator is lacking the entire 3x plus 4. So that's the first thing we're going to do. 3x plus 4 to the top and bottom. And then now the second fraction is actually missing the 8. Okay, so now you've manipulated it enough that you can make it have the same denominator. Remember, this is a quantity that goes together, so you do have to distribute that 3. So sometimes that's where people mess up. Alright, so here's your first fraction. Here's your second one. And if you'll notice, I don't ever distribute the denominator back together. I don't think you really need to, unless you have an instructor that tells you otherwise, then you can do it. But I just go ahead and keep it as simple as possible. Alright, so now I'm going to add the parts together. So I got 9x plus, I believe that's 36. And then just make sure, see if you can factor that top a little more. I think you can take out 3 GCF, and then you should have 3x plus. Oh, just kidding. No, that's not the biggest thing you can take out. Definitely a 9. My bad. Alright. And then, so if we take out a 9, then we're left with x plus 4. We got 8 on the bottom, 3x plus 4. I don't see anything that we can reduce, so that would be your final answer. And then just remember that both of those are equivalent. So either one of those would be correct. You would not see both of those on a test, I promise. Alright, so let's do subtraction now. It is pretty much the same thing. You're just subtracting. So I guess let's go ahead and factor that second denominator just a little bit more. It has a 4 GCF, so 3x minus. I'll tell you what, I don't want to do that. Let's back up for a minute. So if we have factored it, that's perfectly fine, but it's not necessary at this point. So notice the first one is missing 12x minus 8. So I'm going to do that to the top and bottom. And then the second fraction is missing 3. Remember that this goes together, so I'm going to distribute that. So I got 84x minus 56 divided by 3, parentheses, 12x minus 8 minus 24. Okay, so the only thing that's changed is that now we have a subtraction sign. Just make sure you're subtracting. Really not a big deal. So don't do anything to the bottom. Okay. And then at the very end, I'm just going to see if I can simplify it a little bit further. So I got an 8 GCF. I'm left with this. So I was going to factor out that denominator at the very beginning. I didn't, but now I'm going to do it. So there's actually a 4 GCF I could take out. So I'm going to write it like this. Okay. So I can even make that a little bit easier. So 8 is really like 2 times 2 times 2. 4 is 2 times 2. So if we had factored it at the very beginning, it would have worked, but I just waited till the end. Alright, so I'm just looking for things they have in common. A 2 and another 2. And now I'm just going to write it. So there's a 2, there's a 3, and a 3 minus 5. That's my answer. Alright, so we're going to do the same thing. Remember that these quantities go together because of that plus, they're binomial. So when you're trying to figure out what they need, you might want to put them like in parentheses, just like I did. That kind of helps me remember them. Alright, So I'm looking at the first denominator. The first denominator is lacking the x plus 2. So I'm going to do that to the top and bottom. And now I'm looking at the second denominator. It's missing an x plus 1. Alright, I want you to go ahead and see if you can distribute that together. Alright, so this is what you should have. So remember the denominator, we're not going to do anything to. The top gets a little bit trickier. So what I want to do is I want you to think of it like this. So we are subtracting this entire quantity 2x plus 2. So when we get to this is when we would actually distribute that negative sign. So it's really 4x plus 8 minus 2x minus 2, because we are subtracting this entire quantity up here. And now when we get our like terms together, it's actually going to be a 2x plus 6. So that's the hardest part about subtracting, I think, is just remembering to distribute and get your like terms together. So we can do the same thing that we have been doing. I'm going to look for a GCF, 2, but this time there's nothing to cancel out, which is perfectly fine. Sometimes it works like that. But this would be not too bad. Alright, so I want you to try this one. And it is the same one that you just tried previously. It just now has a subtraction sign. So it should be pretty easy. So hit pause and 1, 2, 3. Okay, so in red I put what was missing from the first fraction, and then in green I put what was missing from the second fraction. And now I have distributed everything together. And now I did nothing to the bottom. I combined the two tops. And I simplified as much as possible. That is my final answer. Okay, that's the end of the video. Hope it made sense. If not, please email me.